Okay, get back to the heat application. Okay, for the heat application PDE application, maybe I call it that as a PDE application, application. Okay, PDE heat application, sorry. Okay, PDE application. Okay, let me quickly go through with you this, because there are a lot to teach here, but I'll try to cover. This is a very important topic. Every year this will be evaluated, and this heat and wave will be discussed very extensively in the PDE topic. Therefore, and you should master the skill to handle these problems. Okay, let me start with a very quick explanation for the heat equation. What is heat equation and how to handle the heat equation? Okay, I won't take too long, just because I want to the next session, the wave equation, I will upload it in next sessions. Okay, now first of all, you need to take it as a we one rod. Okay, take it a rod. Okay, the rod will be, okay, you can treat this as a coordinate system for the x here. Therefore, this is, you can imagine this is an x, this could be not yet, we don't know, maybe this could be a y, but we are not going to use that as y. Instead, we're going to use that as a t or these things. But let's say this is 0, this is L. Okay, one rod, and there are two things to understand the process, okay, of the application of the heat progression inside the rod. Okay, the first thing, just to define, x equals to distance. Okay, we refer x as a distance and t as a time, and see whether you can see that. Okay, okay, t, okay, I hope that you can see that very clearly. U equals to temperature. Okay, temperature. Okay, now I would like to give you few these things. The heat equations always will be equated with this. Okay, KUXX. Okay, the first question, sir, where did you get this equation and how the equation connected to this? Yes. Let me explain to you later. Just give me 1 minute. I will explain to you how this one is connected to this equation. And this one is a 0t. We call it condition. But what condition is this? Let me write down first. L t equals to 0. You will see how many conditions? 3 conditions. For heat equation, you will see 3 conditions: x0, fx. Okay, number 4. Okay, now we know x is referring to the distance. Okay, x referring to the distance, right? Okay, if it's referring to the distance, this condition 0 to the L, 0 to the L, we call this as a boundary condition. Boundary condition. Why we call it that as a boundary? Because it's refer to distance, right? Distance. Okay, therefore we call it this as a boundary. Okay, boundary condition. This one refer to the t, right? T. Therefore the t is a beginning, right? T is a 0, therefore we call it this as a initial condition. Okay, there are two type of conditions. One is a boundary condition, one we call it as a initial condition. Okay, initial means you initiate based on the time. This is based on time. This one is a boundary condition, is a based on distance. Okay, because refer to distance. Okay, now you understood the basic condition logics. Okay, but now I want you to really able to visualize. You should able to visualize the problem comfortably. Okay, I want you to understand. Okay, you must have a proper understanding on this. Okay, why are we equating, and what is this boundary condition means, and etc, etc. Okay, now let me put it to you. Before I explain to you this equation, let me explain to you this. Okay, it say first U. What is the reference of the U? U means is a temperature. Temperature at the 0 point here, wherever the T can be any, it can be 1, 2, 3, 4, 5, 6, 7, whatever, is a 0. That means at this particular point, okay, the temperature can be at 0, right? 0, it can be anything here. I don't care. It can be for example 0, 0. It can be a U 0, 1. It can be the time. Time can progress. Okay, you take your what do you call your watch, stopwatch, and you start run it to maybe 0, 2. Okay, it may be a 1 minute, 2 minute, 3 minute here. It must be continuously 0. Okay, that's the first message here. Okay, it must be 0. That means the idea here, there is a kind of insulation. Okay, there is a insulations. Okay, they already control here. Okay, where the temperature always is a 0. They control the temperature to make it 0. Okay, similarly the L here, okay, at this particular point, okay, where the temperature L to T can be any value. They say any value. You run it, your clock, to 0, 1, 2, 3, 4, 0 is a 0. Okay, U, L, 1 equals to 0. 2, 3 minutes, 4 minutes, 5 minutes, 6 minutes, still it will be 0. That means here also there is an insulation. Insulation. Okay, they already control. Okay, this is, we call it as insulation. Okay, this is a very proper understanding. Okay, you must have this understanding, otherwise you won't know what is going on inside. Okay, the next thing here, okay, you already insulated at both side, both end, the boundary. Okay, that's why we call it, this is a boundary condition. Okay, now what about this equation? What is this equation is saying? This equation saying, okay, let me chop it into, not chop it, okay, we use a kind of coordinate system here. I call it here, for example, 1, for example, 1. I call it here 2, I call it here 3, I call it here 4, and etc, etc, if I go that way. If I put it that way, that means I make it a segment here. Okay, inside the segment, this is a 2, right? In this segment, if I place x equals to 2, okay, the initial condition of this 0 will control by this 2, the f2. Okay, let's say fx is something called x. That means the temperature over here is a 2, the temperature here become 1, the temperature here become 3, the temperature here become 4. If I assume fx is a 0, if I assume, okay, fx is a x, okay, then now I hope that you got it right. That means the temperature flow, that means something, there is a out source, there is a source actually heating here, different source heating, giving heat in a different way. That means this, in the initial condition, remember this is the initial condition. At the beginning, almost all the point here controlled by this at the initial, okay, at the initial controlled by this. Later it become a 0, 1, 2, 3, 4, 5. That's where what you're going to calculate here. Okay, if the case is something, if somebody asking you, okay, can you give me what is the for example, if the case is something, the time is 3 minutes, it's not anymore, okay, remember, it's not anymore initial, the minutes is already 3 minutes, okay, at the place 1, what is the temperature? Okay, if they ask you this, you won't be able to answer with this. You need to solve it. You need to solve this, then only you able to answer this question. Okay, the solution is later. I'll show you how to solve straight away. Okay, but in the early case, I want you to understand the logics of this equations. What is this equation is saying? Okay, now we go into this equation. This equation, something wonderful. How could they found this ut equals to kuxx? I want you to really, penetrate into this formula to get some understanding on this. Okay, really I'm interested to explain this into detail, but as you all know, we don't have much time because I'm using a recording here. Okay, let me put it to you this way. The first ut, okay, ut is a okay, I'll just quick. Okay, ut can be explained as from your understanding, that based on the, okay, you can, this is equate to the u del t, right? Can I say that? Okay, the changes of temperature for the del t. Okay, this in the official representation of this is a limit del t 0 u t for the small change ut del t, okay, which representing the ut, right? It means, okay, I take it a chunk of the rod, okay, chunk of the rod, the t progress to the t plus del t. Okay, I am taking the chunk of the change, therefore I am looking at the temperature, changes of the temperature for this del t. Okay, my observation is this. Okay, the changes, what is changes going on for the small change of temperature, for the time. Okay, the changes of the time, small change of the time, what is the temperature change, okay, for the particular location. It could be location. Don't imagine this is the whole rod. I'm saying at this particular time, it could be it's not a rod. Remember, rod is a very big one. The temperature can move up like that as well. Okay, the temperature can move up like that. Okay, if the point is something in the middle, okay, the temperature can move up, or it may move like that. Okay, remember on the rod, if I take it a small portion of that, the temperature may move down, move up, move side by side. Therefore remember, this is a temperature, it's not a distance. You don't imagine this as a distance, it's a temperature. Okay, time. I always say temperature is this for the time. okay, for the time, okay, for the time, particular time, okay, for the particular time, the temperature may move in a different direction, okay, not necessarily it will cover the distance, okay. That's the idea that they are discussing here. Okay, what about the uxx? Okay, uxx is referring to the limit, okay, for the del t equals to 0. I give you very quick understanding on this. Okay, x 2u x plus u x minus del x, okay, divide with the del t, not del t, oh sorry, x, this is must be x, okay, if I put a t it's wrong already, okay, del x. Okay, with this del x, what is the idea that I can refer to? This one is a rod. We are referring to the rod change. You see, at the rod particularly, we can take a portion of here, the portion of here, okay. This at the middle point of the x, I'm going here to the x plus del x. I'm going at the back, which is x minus del x. That means I'm taking first not only the future progression, I'm taking the past. I'm taking the past and future, the combination of the past and future inside here. Can you see that? The past at the moment and the future changes. All the possible changes that I'm included inside here, okay, possible changes here for the particular range of that. Therefore, they found this equation telling us the change of the ut can be equated to the constant of this xx, okay. That's what a level that I can explain to you. I don't want to go too detail about this, but at this moment I hope that this basic understanding may give you some idea, understanding, okay, something I want you to appreciate, okay, how the process of the heat flow taking place inside the rod, okay. Now with that one, let me start with the explanation of how to solve this problem, okay. Now based on that, as we know, from example 5, if I'm not wrong, is it example 5? Okay, we already learned u xt is x t t, okay, is number 5, okay, number 5. Then 5 placed inside the 1, you get a t, okay, which is ct x lambda, okay, 6. Therefore, as we know, we already learned before, lambda equals to p2 equals to greater. There are 3 solutions for this, okay, as we all know, we already learned this before, okay. Then I put it there as for the case 1 by 1, okay, t a c, first case only, k p2t x, this can be a b e p x plus c 1, maybe 1 or c, leave it c, no point, e negative px, okay. Combination of this will give us what? Okay, the combination of this may give us what? This combination will give us one solution, as previously we discussed there, okay. But a b times with the things here, then we just can write down here kp2t, okay, bracket, maybe I call it d, okay. After a times b, we call it that as a d, no problem, but it cannot be same, right? Okay, d e p x f E negative px. Okay, this is one of the solutions for this combination, right? Okay, once we solve it, we get a one solid combination. Okay, in this case, in the actual cases, in the exam, you are not required to do this. I'm showing for the first case only. After this, I will teach you the simplified version, which you're not required to do all these things again and again and again. Okay, don't worry, this is a learning. The first process is a learning. I want you to learn. Okay, sometime you will be asked to prove step by step. Therefore, you will be evaluated for this kind of explanation as well. Therefore, I think it's my obligation to you to teach you this part as well. Okay, now with that, okay, now what about the next? If the case is the combination you have done, right? Therefore, okay, in this particular case, we try to apply now. Okay, we try to apply the condition. Okay, we call it this equation as 6, 7. Okay, I want you to apply the condition, which is boundary condition. Always you must use a boundary condition for the first evaluation. Then second evaluation, then only you need to go to the initial condition. All the time, that is how it works. You cannot go to the initial condition and after that test the boundary condition. First you solve the boundary condition. After that only, then only you should able to go for the initial condition. Now, therefore, when you try for the initial condition here, you can see this is xt, right? Let me write here. E k p to t d e p x f e negative px. Okay, with that, if I set this as a boundary condition for the testing, which it will give me, remember this 0 and t equals to t. That's what the message is saying here. Okay, can you get the things clearly? Therefore, the x representation becomes 0. Okay, the x representation becomes 0. Therefore, you will get here k p t. Okay, where you get a d plus f equals to 0. Okay, in this scenario, we know this one cannot be 0. By of course, if it is a 0, the whole thing, we cannot say temperature becomes 0. How can temperature can be 0? Impossible. Okay, why temperature cannot be 0? We already learned. Okay, temperature at the boundary can be 0, but in the middle cannot. Therefore, this cannot be 0. Therefore, E k p to t cannot be 0. And we have other options. Either d plus f equals to 0. Therefore, we can say in this case d equals to negative f. Okay, now you try for the second one. Okay, you try for the second boundary condition. Actually, I should follow one by one, step by step. This is number 7. Okay, you see this is 7, right? Just now, then I should say 7. That means boundary condition 2 in 7. That means this is 2 in 7. That's how you should address. This is the proper way to write. I want you to learn this technique, 2 in 7. Actually, you're using boundary condition number 2 in 7. Now, you're going to use 3 in 7. Okay, we're going to use a 3 in 7. That means here you're using L T, okay, T XL T equals to, okay, now can we, since this is a D, you go back again, Kp2t, this is a dEpx, minus f is a minus d back E negative px, which is equals to 0. Alright, this is L, remember L, okay, since this is L. Okay, again this cannot be, Ekp2t cannot be 0, of course. And do you think this EPL negative PL will be 0? Definitely not, right? Therefore we know EPL, okay, minus E negative PL cannot be 0, impossible. Okay, I want you to think why. Okay, simple only, it's a very simple to understand the whole process. Okay, then we know, because we already say P is a greater than P, we already say P is a greater than 0. Okay, therefore it cannot be 0 in any circumstances. Okay, in that particular case we know, although you make it 0, E cannot be a 0 in any say, therefore D is a 0. Once D is a 0, F is a 0, that means the whole solution is a 0. D is a 0, F is a 0, the whole thing is a 0, therefore this cannot be applied. That means this equation cannot be used. That means it's a D equals to 0, F equals to 0. You cannot use this equation. You cannot use this Kp2 T dEpx plus Fe negative px cannot be used. Cannot be used as a solution. Cannot be used as a solution because you get a 0. Okay. Similarly, if you work for the lambda P2 equals to 0, you get a U xt ax plus b. Okay, it's a meaningless if you apply. Okay, this is actually, this is, I try to put it this as a 8, and when you try to apply the boundary condition, automatically already is a meaningless. Okay, that means it's a if I use a 2 in 8, okay, you see 0, I apply 0, you get a b equals to 0, immediately b equals to 0. Okay, once b is a 0, similarly a become a 0. Therefore, this also meaningless. Okay, you apply 2 and 3 in 8. Okay, this will give us a equals to b equals to 0. Still, this one again is not a solution. It's not a solution. This is not a solution. Okay, now you know both equation cannot be solution. Therefore, finally we have one more option to us to work with, is a negative P2. Okay, with that, can I solve the equation? Yes, this is, I want you to know the x is always is a cos px, b sin px. Learn to segregate the equation this way. It's easy for you to understand the whole process. Now I combine the x and t, okay, which you will get again e negative kp2t. Why you get a negative here? Okay, because it's a negative, remember this is negative. Okay, therefore d cos px f sin px. Okay, this is very important. Please follow me carefully and to understand this example. Therefore I call it this equation as number 9. Okay, this I call it, this is number 9. Now Shall we work on the logics of this? Okay, 2 in 9. If I place 2 in number 9, okay, the first one is a U0T. What I get? I get a, see, 0. Once go in X, sign is a 0, then I get a DEKP2T, which will give me 0. Okay, then very obvious, it lead to D equals to 0, not K. Okay, we already done that. Therefore, D is a 0. This one is 0 already. Okay, now our question is, what is F? Okay, F. What is F? Okay, if D is a 0, okay, we have the equation will be, now our new equation, if I use 3 in 9, okay, 3 in 9, okay, what you will get when you start doing this, you will have U L T, which will give us, okay, because since D is a 0, okay, since D equals to 0, you will have a negative KP2T. We have F sine PL, okay, equals to 0. Okay, this is the challenge that we have. We know this one is not 0. This one is not equals to 0. Now only we have option here to challenge here. Okay, which challenging us. Once we say F equals to 0, we don't have solution at all. Therefore, can I look for the way to say I don't want to make it F equal to 0. Instead, can I make it this one is a 0? Can. Okay, how? We will see this. We have two option only. We have two option. Okay, sine PL equals to 0. If, oh sorry, cannot see, right? If F equals to 0, then no solution. No solution for the equation. Okay, no solution for the equation. If F not equals to 0, then I need to make it sine PL equals to 0. Yes, if when the sine PL become a 0, when sine PL become a 0, whenever PL equals to n pi. Okay, you try and see, n pi 1 by 1, the whole thing become a 0. Yes, then can I say the Pn become n pi to the L? Okay, therefore PL become n pi, then n is this. Therefore remember, n can be 0, 1, 2, 3. Okay, try and see. 0, yes, 0. Okay, 1, yes, pi, still 0. 2, 0, yes. Continuously you can see, you can test and see this is 0. Therefore, now we got a new formula, because since n play the role here, we will write this equation as for the x here, for the x alone here, because we know already A cannot use, we have only the B part here, because A is a 0. Why? Because we already say conform for the D, cos side is a 0. This cannot be used. We have only this equation. Therefore, xn for this is a Bn, where sine is the combination of Pn. I don't want to substitute here yet. Okay, but you just have a look on that. We have a Pn, okay, Pnx, okay, Pnx, where the Pnx is a n pi L, okay, equals to, okay, I just write for you, Bn sine Pn, instead Pn I'll write here n pi Lx. Okay, this is a very important conclusion that we made. Okay, we made out of this conclusion, then we know T. Again we put, since it's n is controlling the Pn here, therefore n Tn is become C, maybe I call it C here, E negative k P to n. We use a Pn, later we can convert Pn is equals to this, is a T. Therefore the combination of this, again another combination of this is become again Un xt. Okay, xt is a xn Tn. Therefore overall when we combine these together, let's say Bn to the C, I call it a small b. I want you to see this equation, which is, you have seen this before. You have seen, remember? Okay, some of you may get this quickly, you will get upset. So how can okay, you must understand this, what I mean by Tn is very important. Okay, sometimes some students never get it. If T equals to 0, what you will get it? You get a B0 sine 0x, right? This is a 0 pi Lx. Therefore you get a 0, you get a 0. Okay, if I choose 1, okay, this become B1. Now you see the challenge here, and is a 1 pi over Lx. X2 B2 sine pi 2 pi over Lx. See? Okay, we know this combination of this, okay, we add together, is a, the Un is a superposition, linearity of principle of superposition. When we use a linearity of superposition, okay, all this can be a solution for the xn. Okay, the xn can represent by any combination of this. Therefore you can see the xn can be equated with this. Therefore I'll write this in this way: Bn sine Pnx E negative k Pnt. But in what way I get this? Because remember, because the Bn is a 1, I get a 1, I can plus how many times? This is, we call it as a linearity of, because of principle, linearity principle of superposition. Okay, we can combine the whole solution. You see, this first one, second one, all you can combine into one. If you remember back, if you cannot understand this, please remember back the solution for the complementary and specific. Okay, that is following the linearity of principle. Okay, principle of superposition. Okay, superposition. That's why we are using this as a something like that. This is the whole very important solution you have done. Okay, we have done one very good solution. Okay, done. Is it enough? No, this is not finished yet. Okay, this is not finished yet. We need to find out the Bn. Okay, we need to find out the Bn. What is the way to find out the Bn? Okay, we need to use what we call, I call it this as what? I call it this as how long do you have? I have 30 minutes. Okay, I call it this as number, I forgot number 10. What? Number 10. Okay, I call it this number 11. Can I? Okay, maybe I call it this is 11 as a solution. Okay, from 4. Okay, from 4. What is 4? For the equation, this is number 4. Okay, I need to use number 4. We know x, t equals to 0. If t equals to 0, okay, we get a t equals to 0. You see x equals to 0. We have fx in 11. Okay, in 11 we get a here fx. We get this what we called as a bn. Remember, okay, can I start with the 0? Can, because n is start with the 0, but no point for the sign. But anyway, keep it to this. Okay, you should know n must begin with the 0. It cannot start with the 1. Therefore, this is 0, but don't worry, when you place the 0, it's automatically, it will disappear. Okay, therefore, in this particular case, you will have the b end, which is b end. The kpt will disappear